All right. So what I'm going to do tonight is I'm not going to try to do too much with you because after thinking about things, I think we're going to do one example of how to do a regression, different parts of it. We'll use both Minitab and also Excel. I've set up an Excel spreadsheet. I haven't shared it with you yet because I was just finished it a little while ago. So I'll post it, but I wanted to bring out some points about Minitab so that you'll understand. And when I ask you to do this project that's coming up, that you may need to use Excel also. Let's get started. You both have your books with you, is that correct?
Yes.
I want you to turn to page 560 in the book. Before we do the actual problem, the regression problem that I'll be talking about, I want you to focus on problem 15.5 on that page. Now on this page, Rose, if you'll have to have your book with you too when you're listening to this video. 5 tells you to, well, actually it doesn't tell you to do a scatter plot, but it gives you 5 points. Seems like there's 5 points, maybe 1, 3, 4 points.
Which page again?
560. Very beginning of the chapter. All right. So there's 4 points. You see them listed. They're XY points. And so if you went into Excel, well, actually you could do it in Minitab. You could put those 4 points into Minitab, and then you could do a scatter plot. For example, let me actually share this with you. Let's share Minitab here. All right. So let me actually create another tab here. I'll call 15.5. All right. All right, so I'm creating a second tab. These are just problem numbers. So 15.9 is the one that I'll be doing in a minute. 15.5, I'm going to set up an scatter plot. So in C1, I'll just type in X, right where you would put your variable names, put Y here. And they give you the X, Y points here. So I'm going to just type in the X's and then type in the Y's, right? Obviously. So X's are 5. I'm just going to type those in. And then the Y's are going to be, this is just for the first one. The Y's are going to be what?
10.
10. Okay. 12. Right? 20. And the last one is 16. So we have, all right, so we have 2, 10, 3, 12, 4, 20, 5, 16. Okay. All right. And now they give you. Sorry, what? Say anything?
I just said yes.
Okay. Now they give you 2 equations. Each equation is considered a proposed line of best fit. All right. Now we're not going to use calculus to find the actual line of best fit, but we're comparing these 2 lines. There's 2 possibilities. There's one that says y hat is equal to 10 plus x. And the second one says y hat is equal to 8 plus 2x. So your job in this problem, you can take a few minutes to do this, is find which of these two equations is the better fit for this, for these XY points. Now you can create a scatter plot with this, right? You can go to graph, scatter plot, choose a simple scatter plot, and then just simply put the Y and the X in the proper place. And just click OK, and it'll do a scatter plot for you. So that's the scatter plot. So obviously there could be several lines that could go through these points. It looks like it's upward trending, right? And both these potential lines both have positive slopes. One has a slope of 1, it's a 10 plus x, and the other one has a slope of 2. But we want to determine which one is the better choice based on what we've learned about regression. And what I want you to think about now is how you would propose to pick one of these two lines. Would you just simply plot them and see which one looks better? Or would you use another method? First of all, do you have any ideas of how you would do this problem?
Well, it says to use the least squares rule. Regression line, sorry.
Yeah, but that, so what is that criterion then? What is the criterion? We're not going to use calculus, obviously, so we're not going to use the actual procedure of least squares.
Mm-hmm.
But, right? But
Right.
we're going to be using some criterion related to that. So what would you be doing? What are you going to do? If you're going to put this into a spreadsheet, for example, into Excel instead of Minitab, let's say that's what you're going to end up doing. How would you do it? And Han, you can also give your ideas too. So we have two choices here. It doesn't say one of them is the line of best fit. It just says pick the one that's the better fitting line out of the two. What would you do?
Mm-hmm.
Yes. So how would you do it?
Can I use the regression on Minitab?
Yeah, but the regression of Minitabs, it's going to give you the line of best fit. It may not be either one of these two lines.
But the slope, I want to choose the slope which is closer to the actual line. That will
Well, the line of best fit
work.
is the regression line, right? But that's the Minitab uses and also Excel too would be able to do it, which I'll show you. Minitab uses calculus, just like Excel would use calculus. We're not using calculus. We're not even determining what the line of best fit is. They're proposing two lines here. They're saying which one is the better fit based on the least squares criteria. So what would you do? That's what I'm asking.
Generate our own least squares regression line and then compare it to the options they offer.
Okay, and how would you do that?
Use
you mean find the best fit line and then compare it to the two lines? How would you do that? How would you make that comparison?
Subtract the one that you generate from each one and see which one gives you a lower one.
Okay, but what are you going to subtract? You said subtract. I don't know what you mean by subtract.
Oh, well, you use the data and get your own regression line, and then you subtract that from each of the options they give you, and whatever's lowest. That would be my guess.
Okay. All right. Han, do you have an idea?
I feel like we can plug in the X and to see which Y number is closer to.
Good. So Han, what you're recommending is you can do it for both lines, right? You can plot the actual, for each X, you can plot the Ys, correct? And then what would you do? So that actually is closest to what the solution is. Go ahead. So what else would you do?
Mm,
But once you do that,
if we plug in y, we're gonna compare which x is closer
closer to
to
what? Closer to what?
closer to what?
I don't know. I'm being very precise, but the precision will help you solve the problem. Steve, you can chime in too, because Han is actually close to what you can do.
I will when I feel confident.
All right, all right. So no, you're close, Han. I want you to think about it, work it out in your head. Once you let's say you plotted the two lines, right? You've plotted them for each one of these four x's. What would be your next step?
Oh, you just calculate the residuals and whichever gives you lower values for the residuals,
All right, and how would you do that, Steve? How would you figure out the
or
lowest?
whatever gives you a closer to zero value.
What's zero?
For each,
The what?
so you take the line's predicted y value for each point where there's an x value, and then you subtract the actual y value from that predicted y value for each one, and then add all those up, and then the closest to z.
Well, I'll tell you one thing, Steve.
Whatever's closer to zero between those two
When you do
sums
that,
is the better one to use.
you're not going to be able to come to a conclusion, because when you add up the residuals, you're always going to get zero.
Oh, right, yeah.
Right?
Where?
Squares, right? And then when you add up the residual squares, what are you looking for? For both lines, you're going to get different answers, right?
Mhm.
So what are you looking for?
The smaller one.
The smaller one, right? All right. So go ahead and do it. You know what to do now. I'm going to mute myself for 10 minutes. I'm going to let you work on it for 10 minutes, all right?
Okay.
And it looks like you both are ready, right? Okay, so tell me what the sum of the residual squares are for both. What did you get for the line number one? For those, for that one?
Is it 42?
Okay. Han, do you agree?
No.
42?
What's that?
The sum of the residual square for line number one.
Number one. Number one is 3x. No, I got 65.
All right.
You might be right. I don't know.
How
No.
about number two? What did you get for the sum of the residual square for number two?
I got 48.
I got 28.
28. Okay. So we're going to look at the back of the book here. I did a different problem, not this one, when I went through this exercise. So the back of the book, this is problem number 5. Well, it just gives you which one. It says the second one. Well, that I guess you both agree the second one, right?
Yeah,
Yes.
we do.
Just come up with different numbers. All right. So what did you get? Let's see. One thing I forgot to do in my little problem here. Let me see which one of you. So the last point is 516. Okay. All right. So let's see. Y is equal to 16, and y hat would be equal to 15, right? So that's 1 is the residual on that one. Okay. I'm sorry, that's not residual. No, it's just y hat is how much is y hat in this one? Y hat is 16 for the fourth point, and therefore the fourth residual is 1, right? Fourth residual is 16 minus, I'm sorry, the y hat is 15, so 16 minus 15 is 1. Okay. Square that, another one. So I get 42 for the sum of the residuals of line 1. Who got 42?
I got 42. Yeah.
42. Yeah, that's correct. And then for the line number 2, I just didn't put down the fourth one here. The fourth y hat is 18. 18, and then 18 minus, excuse me, 16 minus 18 is negative 2. Negative 2 is the residual for fourth point. That means that that amount squared four. So I got 28. Is that what you got, Steve?
Yeah.
For the second one. All right, so Han, it might be some arithmetic.
Mm.
So Han, tell me let's just take the fourth point. What did you get for y hat for equation 1 for the point number 4, the one that's 5 comma 16? What did you get y hat for that one? An x is 5. What did you get y hat for that one for the first line?
So y hat is like
That's
just
the
one number for,
y hat is it's the predicted value of y for a value of x. That's for a line, for the line. So for line number 1, y hat is 10 plus x. Y hat meaning it's a predicted value. It's not the real value.
okay.
So for the fourth point, where x is 5, what did you get for y hat for that one?
I didn't do that.
All right,
Do it that way.
you have to do that. That's the point. I think you're not doing
Okay.
the arithmetic quite right. So what you have to do is plug in 5 into the equation.
Uh-huh.
That gives you y hat for the fourth point. The way I would write it would be y hat with a little 4 next to it, which indicates that it's the fourth
Mhm.
as the fourth point's estimated y. So I get 15 for that. If you plug in 5 to 10 plus x, you get 15.
Okay.
All right. Then when you do the residual, I'm just showing you how to do it for each
Right.
for that one point. You can do it for all of them.
Mhm.
Then the actual value of y is 16.
Mhm.
So 16 minus 15 is equal to 1. That's the residual for that first line for the fourth point. The residual
Okay.
is 1. 16 minus 15. And then when you square it, you still get 1.
Mhm.
So that's what you have to do for all 4 points.
Okay.
And for
I got
both lines. And then when you do line number 2, you have to come up with your estimated y values based on that line. So for example, for that fourth point, for line number 2, you plug in 5 into 8 plus 2x, you get 18. That's y hat for the fourth point. And
Right.
then y minus y hat is 16 minus 18, which is negative 2. That's the residual for that point, for the second line. And then when you square it, when you square that residual, negative 2 squared is 4. So that's the residual squared for line number 2 for that fourth point. It's 4. Okay. Does that make sense to you?
Yeah, I got it.
All right.
Yes.
So
Yes.
you can redo the others and you'll see that it'll match what Steve got.
Mhm.
All right. I just wanted to make sure that you were doing that correctly. All right.
Yeah.
And of course, Rose, if you're listening, make sure you do the same thing. All right. Now what we're going to do for the rest of the night is focus on number 9, 15.9, which is on the same page. Instead of doing multiple problems here, we're just going to focus on one problem and try to figure out everything that we need to know about that regression. All right, so now we're going to actually find the line of best fit. So what I want you to do is for number 9, and you can do it both in Excel and also in Minitab. Do it in both places, is to enter this data in there. All right, you can call, 15.9, it says the column, that's the X column, it says X is equal to years. You can put either years or say X is equal to years, it doesn't matter. And the Y is shares, and it says that these are employees. There are how many employees? There are 8 employees, and each one of them has a number of years they've worked for this company, and that's the independent variable, X, and Y is the number of shares of the company stock that they own. All right, so there's some sort of profit sharing with that company. So just put in one column, put the X's, and then put in the other column the Y's in that order. Give you 5 minutes to set it up both in Minitab and in Excel. Right, so go ahead and do that, and I'll be able to tell by looking at you when you're ready. Right, and then we'll start playing around a little bit with this. All right, Han and Steve, looks like you're both done. Okay. So what I'm going to do is I'm going to share my screen and we'll look at Minitab. Actually, this is Excel. I don't want to show you this yet. Let's look at Minitab first. Sorry about that. All right. I'm going to turn to 15.9 now. I'm actually going to delete some of these numbers in here, the ones. All right. I won't show you any of this yet. All right. Now, of course, this is not the scatter plot, right? This is not the scatter plot I want. Let's look at the scatter plot first. Actually, when you do any regression, that's one of the first things you should look at. If it's just a simple regression with one independent variable, is to go ahead and look at a scatter plot. All right. So that's what we're going to do. All right. And oops. One second. I think it's already set up, but there we go. All right, so that's the 8 points, and it definitely looks like it's upward sloping. All right. Now, all right, so we're looking at, it looks like it's going to be a linear line that goes through this. It doesn't look like there's any curvature in the points, in the XY points. So it looks like a linear line, looks like a pretty good fit. Just an initial guess. So if we do our regression first, we're going to do regression. So we'll pick regression, stat regression, then regression again, and then fit regression model. And once again, put in the, now the responses here is the Y variable. The continuous predictors, that's the only type of predictor we're going to do in this course. There's obviously categorical predictors. For example, if we wanted gender, age groups, answers yes or no to a question, those, if there were predictors, they would not be continuous, they would be categorical. And there would be a way of coding them so that you can enter them into this model. You would have to code them in a certain way. And that, of course, is a little bit beyond the scope of this course. That's more of a stat 2 thing. So we're going to keep it simple. Just do continuous predictor. That's X. And the Y is going to be our response. All right. Is that clear? And then when we click OK, now if we just click OK, we're going to get a few. We're going to get 2 diagrams in this case here. We're going to get at least the ones I chose, like the normal probability plot and a histogram. Now, I believe there might be others that, but these are the 2 I chose. All right. And if we look at those and actually, fortunately, let me move this out of the way here. I can't see everything. You don't know what I'm talking about, but I have a share thing here from Zoom that's hiding what I want to look at. Let's just take a look at the graphs here. One of the conditions is that the residuals are normally distributed. If the residuals are, by the way, are normally distributed, so are the Ys. Should let you know that. The Y values, the dependent variables, all the Ys are normally distributed. And the way to know this is that if you can draw a line pretty much through these residuals. Now, these aren't the original X's or Y's, these are the residuals. This is Y minus Y hat for each one of these. All right. And they're being expressed along here, along the X-axis. Okay. So a line it can be drawn through these, and it looks pretty linear. So when you see a straight line that can be drawn through the residuals, then this is an indication, one indication of normal, approximately a normal condition for the residuals, and therefore a normal condition for the y values. Now the histogram for the residuals, harder to see it that it's normal, right? It might even be, looks like it's even skewed to the right a little bit. But if you broke up these, if you made more of these rectangles, instead of having 5, maybe you had 10 or something, you would see it would be more, it would look more normal. So these are just additional plots that would help somebody determine if the conditions of regression were being met. The independence of the observations, we would assume each employee has nothing to do with any other employee. So that would be also met. And the third condition would have something to do with this variance. Remember, the idea of the variance is fairly constant across the residuals. And this measure here, and this is not something I'll be testing, but this measure here, this VIF measure, has something to do with that. And you'll just have to take my word for it. It's low, it's not too high. And therefore that condition's also being met. All right, so everything looks fine for this regression. Now, what the regression is showing, number one, let me scroll up a little bit. It's giving you an equation. But one of the things I realized when I was going through this problem is this equation, they're rounding. They're doing a lot of rounding with this. This 44, they're rounding to, and I don't know why they do this, to be honest with you. But the rounding here is to the nearest whole number for the 44. It's not 44 exact. It's like 44.4 or 44.3 something. It's not very good. It's not good. All right. And this 38.76 is also rounded, but at least it's rounded to 2 decimal places. So that's better. So this is my point. My point is, when you do some of the predictions, the y-hats, and you say, all right, if I plug in 6 into this equation, I should get a certain value. And then when you look at the y-hats, all of a sudden you're looking at them and saying, wait a minute, that's not the same number. And that's one of the things I noticed too. If you go to, let's go back to the table. Notice here that if you plug in 6 into that equation up here, you do not get exactly 276.849. Get a different number, a little bit. All right, you get something a little smaller than this. And then you're going to start scratching your head and say, what's the problem? Well, the problem is the rounding. So this is not a reliable equation to use. Now, if I was teaching this class to other people, and I wouldn't be going through all this stuff that I'm going through with you now, I just say, all right, just plug it in, get your answer, and good enough. But since we're going through these other things with Minitab, it makes sense to know what the exact equation is. And you can't tell by looking at this equation or looking at the coefficients. Remember, these are the betas. This is the y-intercept. And this is 44 is supposed to be the y-intercept, and the 38.76 is supposed to be the slope. So that's a problem, right? That's an issue. So the question is, how do we come up with the, if I told you, for example, what is the line of best fit, and please round the y-intercept and the slope to 3 decimal places, you certainly can't do it here, you know? So how do you get around that? And the answer is Excel. That's where the answer is going to be. So I'm going to show you Excel, and I've actually created this whole work spreadsheet. You're going to see it. It took a while to get it perfect. It is perfect now. So I'm going to share it with you because I did a lot in a spreadsheet, and I will share it with you guys. You can take it and use it for both the project and the final exam if you wish to use it. You don't have to, but you can use it if you wish. So let's open up Excel. And you can see it's a lot of work here. So I had to make sure that the formulas worked. I didn't expect you to work if you're not, unless you're an Excel power user or something and you are used to doing complicated formulas. I didn't want you to go through all that hassle. So I went through and created the formulas. But this is the data set right on the left here. The X is years, Y is shares. All 8 of them are listed here. Now, before I show you, before I share anything else, one of the things I did for the X's and the Y's is that I added them up. So the sum of the X's is 84. The sum of the Y's is 3610. And I also did the average, the mean for both X and Y. All right. And how do you do the sum? It's just using the sum. Let me just, there we go. The sum function. You always do equal to before you use a function, all right? Equal to any formula. So the sum is just equal, it's equal sum, and then you just scroll down, you just highlight the cells that you're adding up, and then it's C5 through C12 in this case here, and then get 84, and then the average one, you use average for the function, all right? And did the same thing for the Y's. So I have now both the sum and the average for both X's and Y's. I also have a column here where I squared each of the X's, which I need for some of these formulas. So I just did square and then copied the formula down. And this 968 at the bottom is the sum of X squares. All the X squares are being added up, and that's the sum of all those. All right, so how do you come up with the slope and y-intercept, which is more precise? Well, for slope, okay, there's actually a function in Excel called slope, and it is the slope for the regression line. All right, so how that's convenient. You don't have to know the formula that the book tells you, the actual formula. It's already built into Excel. So you just have to say equal slope, and then when you do that, it's going to ask for the y values first, and then comma the x values. You'll see it when you type it in. All right, so equal slope, and then it's going to ask for the y's. So you scroll, you do your highlight the y's first, the 300 to 522, highlight those, and then and then comma highlight the x's, and then see what you get here. It's 38.75581. And I believe, what did Minitab say it was? It was 38.76, I think, for the slope. It rounded it to 2 decimal points. Yeah. Now the y-intercept's the issue with Minitab here, because now what do you use for y-intercept? You use the function intercept, not y-intercept, just intercept, and it is the y-intercept for a regression line. And it's the same thing, the y's come first, comma, then the x's. And notice that Minitab rounded it to 44, but it's actually 44.31395. That's not very good rounding in my book, all right? That's pretty bad rounding. All right, so that is the y-intercept. I left it at 5 decimal places, because that was, but if I made that column in Excel wider, there'd be more decimal places, but that's good enough. So I have my slope and y-intercept now, and therefore I have my line of best fit. All right, so the slope function and the intercept function gives me the estimated betas for the regression line. All right, beta 0, which is the intercept, 44.31395, and beta 1, which is the slope, 38.75581. So this is the better place to find your equation, your regression equation right here. All right, it's going to be y is equal to 44. If we were going to round it to three decimal places, it would be y hat is equal to 44.314 plus 38.756 times x. And that would be your regression line. Okay, that makes sense? And that's it. Now, let me show you what else is on the spreadsheet here so that you understand what I'm doing, because this goes a little bit ahead into the chapters, but I want to show you in general what's here, and then we'll proceed ahead into the different sections of this chapter, and we'll find that almost everything here will be helpful. Now, what is the third one here? This SE estimate. That's the standard error of the estimate. All right, that's the square root of the squared residuals divided by the degrees of freedom, which is n minus 2. That's that form. Remember that? The standard error of the estimate. It's really, another name for that would be the standard error of the residuals. All right. So it's a estimate of the variation of overall variation of the residuals for the whole data set. Not for any particular value of x, but for the whole data set. Now, remember last time, let's actually go back to Minitab. All right, now one of the things that happened when maybe I should redo this here. Let me redo this problem here. I'd like to get rid of these fits and residuals and stuff. And because it's repeated over here too. So kind of annoying. Some of these computer programs, they really are not very good in fixing things up when you want to start all over. So what I'm going to do, actually, I'm going to get rid of this thing here. All right. And I'm going to rerun this analysis now, do another regression. And think about how to do this. All right, I guess I'm going to have to do it again. So I'm going to create a new, I'm going to actually delete 15.9 here. Delete the worksheet. Save worksheet 15 before removing it. No. All right. I'm going to create another. And it'd be helpful for you to see this process again. All right, so I'm going to put into Minitab. So you can just type right in to this row here, just above where the spreadsheet begins. Type in the name of the column. X is equal to years. I think you've already done that, correct? You did that, okay. But this is for the benefit also of rows. And we'll type in shares here. All right, so I'm going to just type in the 8 X's. All right, and now we'll go to the next column. Make sure that I'm doing it right when you see me type it in. Making mistakes. Okay. So let me just take a quick look at the data. Make sure it is correct. That's, when you're doing a test or something and you're being asked to type something in, just double check. Always good to double check these things. All right, that looks okay. And now, again, we're going to start again and do a regression. We'll fit the model. Once again, remember the response is the Y. And the X here, the X goes there. Okay, now let's just see what's in these options down here. Model. No, we're not going to do any sort of modeling other than what's the regular stuff it does here. Options. Now, if we wanted a 95% confidence interval, or let's say a 99% confidence interval, we could put it in here if we wanted to. There's another place you could put it in also. But this would be for if we wanted a confidence interval for the slope. In other words, we're going to end up with an estimated slope for the line of best fit, but remember, it's dependent on the data that you get, right? And if you had another data set, you might end up with a different slope. So that's why confidence interval might make sense to have for this, right? But we'll leave it at 95 for now. Never change. I would never do anything other than a two-sided confidence interval. You could leave this sum of squares alone. That's fine. And we're not doing any transformations in this course. Again, that's beyond first semester in statistics. Weights, definitely, we're not doing any weighting. So we'll leave that as it is. Coding, no coding. This is, again, something advanced that we wouldn't be doing in this course. Stepwise, we're not doing that. Validation, we're not doing that. Okay, graphs. This is where you would choose your graphs. So it's defaulting to a histogram of residuals and a normal probability plot. That's fine. We don't, residuals, regular residuals is fine. We'll just leave it as it is. Results. This is where, if you are in this here, you might see analysis of variance box checked. I would uncheck it because we didn't cover that in this course, and it might be a little confusing to you at this point to see a separate report on analysis of variance. You may not know what that means. So we're going to skip that, all right? Method, fine. Model summary, fine. Coefficients, fine. Regression equation, fine, even though it's not that great. And fits and diagnostics, only for unusual observations. It's okay to leave that checked. Durbin-Watson statistic we didn't cover. We're leaving that unchecked. So the only thing I would uncheck if I got into here was the analysis of variance. I would uncheck that, all right? You may want to make a note of that, not to do that. And storage is something we might use. What's storage? Storage would give you the opportunity to for each value in your data set to store or to display as part of your data set fits and residuals and other things. These other things we're not learning about in this course. It's more advanced. So it's already checked off for you. The fits actually wasn't checked off, but I'm checking it off. So what are the fits? That's the y hats for each of the values in the data set. That's your y hat. All right. And then the residuals is just y minus y hat. So that would save you some time doing the arithmetic here. All right. So if I clicked OK, and then clicked OK again, notice it's going to give me two columns in addition to the columns that I entered. It's going to give me the fits, which is the y's, the y hats, and it'll give me my residuals. All right. And once again, if you plugged in 6 to that equation up here, you're not going to get 276.849. It'll be off a little bit. All right. It's going to make you question again what's going on. Well, again, it's the rounding issue. All right. Now, what else could we do here besides that? All right. So we end up with all of this, right? All of this, including the two graphs. And again, what is all this? The approximate equation. Again, the approximate coefficients. And then this here. Now remember, I went through this last time. The only one that I'm going to have you sort of be responsible for is the R squared. Now, what does the S here represent? The S might be, and I would have to double check this, the S might be the standard deviation of the Y's. That could be what the S is representing here. Standard deviation of the Y's. But it doesn't matter, I'm not going to ask you that because this Excel spreadsheet could easily give me that answer also. The R squared is going to be a measure of how good this overall fit is. Because remember, this equation is using only one independent variable, the predictor, which in this case is what? It's the number of years of service, right? And the number of shares, it's saying it's going to predict the number of shares that the person has. But there could be other variables also that's predicting the number of shares that we may not be aware of, all right? We haven't done any initial investigation and we didn't do any more research. What the R square is telling you is that the total variation of the Y's, which I think is what this S is supposed to represent, the total variation of the Y's, 72% of that is explained by this regression model. And that means that 28% of it is not explained by the regression model. And that's what the residuals are about. The residuals are there to explain that so-called error, the error that is there. And the error is really due to some unknown variation, unknown reason for the variation in the Y's. 28% of the variation in the Y's is unexplained with this model. Now we want the R squared to be high. We'd love it to be in the 90%, all right? Never be 100%. But in reality, in real life, it's going to be lower. And in the social sciences, you get an R squared 30, 35%, you're going, yippee, it's fantastic, because the social sciences are so imprecise. Maybe in biology, maybe in physics, maybe in chemistry, our expectations are higher for R squared. But 72% is okay. All right, overall, that's acceptable. These other two that are mentioned here, let's not even bother with that in this case. We're just going to look at the R squared and just know what it means. All right, it means 72% of the variation of the Y's of the dependent variable are explained by the model, which is, what is the model? One predictor variable, and that's the number of years of service. All right, and what is the Y? Of course, the Y is the number of shares. So the variation in the number of shares is 72% of the variation in the shares is explained by years of service. That would be the way to say it. All right, so that's what we see here. The normal probability plot again looks good. You know, all these residuals are hugging this straight line here, which indicates fairly normal distribution for the residuals, and therefore fairly normal distribution for the Y's, which is good for doing this type of analysis. What if we wanted to know the correlation? Well, if we go to stat again and go to, let's go to regression. No, go to stat, go to basic statistics. So stat, so not the regression, stat, basic statistics, and scroll down to correlation. And we simply highlight X and Y. So I'm going to use my control key and highlight both and then click OK. It's not letting me do that. So I guess I just have to do one at a time. just click OK, and it'll give me a scatter plot. Notice that the scatter plot, there's another place you could do a scatter plot. You don't even have to do the scatter plot. You could do the correlation, and it gives you a scatter plot. And then right over here, the 0.849 gives you the correlation. It even gives you the confidence interval for this correlation. Now in this chapter, they do show you how to come up with a confidence interval using formulas. Come up with a confidence interval, but obviously you don't need to do that. It gives you the confidence interval right here for that correlation of 0.849. And this is a 95% confidence interval. Now, in simple linear regression, where we have one predictor variable, if you square this number, 0.849, you should get the R squared. All right. And R squared, another name for it, is the coefficient of determination. That's another name for R squared, the coefficient of determination. It's in your book. All right. So R squared, the correlation squared, gives you R squared. That's another way of finding it. They do show you a formula in the book of how to calculate it, but you don't need to do that. So this is strong correlation, right? Strong positive correlation. Notice that the correlation coefficient is positive. That should match the slope of the line of best fit in terms of sign. They'll never be different signs. They'll be the same sign. So if the correlation is positive, so will the slope of the line of best fit be positive. If it's negative, the slope of best fit will be negative. Okay? Makes sense. Any questions about that? Where to find correlation? It's right here. Right. So it's basic statistics, and you scroll all the way down to correlation, and that's where you'll find it. All right. Now, let's go back to but you have a question. Go ahead.
No, I just said okay. Sorry. There's a delay.
Okay. So let's go back to regression. And notice we can go down to predict. Predict means not just prediction intervals, it means confidence intervals too. I should just let you know, it means both. Now, you have a choice here. By the way, it automatically puts in the Y value. All right, it knows what the Y is. Because you run regression. You have to run your regression first, by the way. All right, don't do this first because it doesn't know what Y is. So this is something you do after you've run your fitting the regression. You do this next. And suppose you wanted to predict, let's say every single one of these, you want to have a confidence interval and a prediction interval for each one of these values. And maybe you want one for some other value. You could put that other value in here too, and it will do it. And if I were you, because of the clunkiness of this program, and it is very clunky, there's not much flexibility in this program. If you were going to wanted to know the confidence intervals and prediction intervals for each one of these values, put them in order. Put them in order. And we'll see how it comes up. Put them in order, and then put the last. If you wanted to have a confidence interval and prediction interval for an additional value, put that at the end. All right. Put it at the end. Otherwise, you're going to end up with a mess here. But let's see how it works. I'm curious. I'm going to type in my X values in the order that they're shown in the data set. All right. So we're going to do 6 and 12. See, you have to keep pointing your cursor with this. This is a very clunky program. 6. The next one is going to be 9. And after 9 comes 13. The next one's going to be, what is it? 15 and then 9. 15 and then 9. And also let's put in 10. Let's put in 10 because that's not in the data set. That'll be an initial value. Let's see if it actually puts it at the very end. All right. All right. So we have the 8 values plus an additional value 10, which is not in our data set. And let's look at the various choices here. Options. What's options going to give us? Well, we can choose a different confidence level and prediction level here. All right. If we don't want a 95%, we could choose a different one right here for these. All right. So if I ask for a 99%, you type it in. It will be defaulted to a 0.95. All right. Actually, let's go out of it. Let me see something here. Let's go back. It actually doesn't have a dot next to it, does it? It looks like you can put in the full percent. Again, this is very crazy. All right. You type in help, by the way, it'll help you what to put in. It'll actually take you to the internet. Then you tap internet. But it doesn't tell you what to do. It doesn't tell you whether you should put 0.99 or put in 99. Yeah. Kind of annoying. All right. So I'm going to put in, let's go back. Are you seeing what I'm saying?
Yeah.
Yeah, you do. All right, good. Let's go back to Minitab now. I'm going to leave it at 99 and not put 0.99. For some reason, it seems like it's doing a percentage here, which is strange. I'll click OK. Results. It says it'll produce a regression equation and a prediction table. Okay, I'll leave it at both. Now, what does that mean? It means it's going to put something up here, and where it displays all this the results. It'll produce the regression equation and the prediction table. So I'll say yes to that. And storage. What do I want? I want the predicted fit. Now we already have the predicted fits, right? I already asked for it earlier. Don't need that anymore. I'm going to remember I told you last time the standard error predicted fits, didn't know what that is? I know what it is now.
What is it?
I'll tell you in a second.
Okay.
I'll keep you in suspense. Confidence in limits, prediction limits. I want those. Click OK. You model. Fine. Click OK. Let's see what happens. And look what happens. This is why you have to do it in the order that the data set's in, because it will put them in that order. All right. Plus, let me actually show you the data set now. Data only. Notice that for X is 10. Notice it doesn't even type in the 10 here. You have to type it in. All right. That is so ridiculous that they didn't even bother programming it so that it puts the 10 in there for you. All right. But it doesn't calculate the Y because we don't have a Y. It doesn't predict fits because there's no Y hats. Right? Or should it have a Y hat? Well, for this one, we should have a Y hat, right?
They could just take the mean of the confidence limits, right?
No. It should have a Y. It should have a Y hat here because it's just 10 into that equation. Should give you the
right.
Y.
Yeah. Yeah.
So I already had it here.
Because that's the previous.
Yeah. I didn't bother. It would have given me that number, I think. The fit. So actually, I know what it is. I'm going to go back to my Excel spreadsheet. Oops, sorry about that. Let me share that with you. Back to the Excel spreadsheet, and suppose I wanted to know the predicted value of y. I'm going to put another value right into the spreadsheet here. I'm going to type in 10. Okay, x is 10. And I want to know what? I want to know the predicted value, right?
Mhm.
All right. So I'm going to just scroll up to one of these formulas. It doesn't matter which one. And copy. And I'll paste it right down here. And there's my predicted value for 10. 431.872. 431.872. All right. So 431.872 should be my predicted value. Right here, 431. 431 point, what is it, 872, right? 872.
Yes.
All right. That's why the Excel spreadsheet is helpful. All right. No residuals, because we don't have a Y. That's blank too. But we do have this. PSE fits. What the heck is that? What are these PSE fits? All right. These are the standard errors that, for each one of these. Notice that for each one of these values has a different standard error. What the heck is that? I will tell you what it is. It is, now let me think about it for a minute. All right. It is the following. It is the standard error of the estimate, that square root formula. Remember that square root of the squared residuals divided by the degrees of freedom, times that square root thing that's in these formulas. Remember the square root with all that stuff inside of it? 1 over n plus blah, 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 blah. Remember that from last time? Well, that's, if you multiply those two numbers, you get these. The standard error of the estimate's the
Why
same.
will we,
What? What was that?
why will we time that two number?
By the square root in, I guess I have to show you the book. Or actually you can turn, let me show you what, tell you what page. And actually, at the end of the chapter, there's a summary of all the equations. Go to page 589. 589 in your textbook. You there? See all those
Yep.
formulas? Look at the fourth formula down. For the confidence interval for a mean given a specific value of x. That's square root I'm referring to. That thing. If you take that and multiply it by s, that sy dot x, which is the standard error of the estimate, that's what this standard error of fit, this standard error of fitting is. It is the multiplication of those two numbers. It is the standard error for the confidence interval that you create for each one of these x's here. Okay? Not for the prediction interval, by the way, it's for the confidence interval. So let's go back to the Excel spreadsheet and I'll prove it to you. Yeah, we're doing with time. This number here, 91.4793, that's the standard error of the estimate. This CI square root here that I created a column for is that square root. I've created a formula for that. Okay. So for example, for x is equal to 6, this 91.47893 times This 0.60038,747, those two together should give us that number that we were just looking at. So let's do that. I'm going to multiply those two numbers with my calculator. 91.47893 times 0.600038,747. All right, I'm just going to multiply those two numbers. I got 54.891 approximately. Now I'll go back to Minitab. And slightly off, but this is it right here. Probably just some rounding error, but that's it, 54.9228. They probably just to be honest with you, they probably just multiplied. Well, I don't know what they did, some rounding issue there, but it's pretty much the same number. I got 54.891, 54.9228 is pretty close. And that is what this is. It's a standard error for that confidence interval. Remember, a margin of error in a confidence interval is a critical value times a standard error. Remember I mentioned that a while ago when we did confidence intervals? The margin of error, which we add and subtract to our estimate to get a confidence interval. Margin of error is the standard error times a critical value. So the standard error here in this particular formula has two parts to it. It has the standard error of the estimate times the square root thing. And that gives us the standard error for this confidence interval. And then when we multiply it by the critical value, we get our margin of error, which we add and subtract to get our confidence interval. So let's take a look at let's look at the confidence interval for when x is equal to 6. We see that the lower end is 73.226. Let's go back to the Excel spreadsheet, see if it matches. Here it is, 73.226. Okay, so it comes out pretty well, doesn't it? It comes out. Wait a minute. I just went back to the, sorry, went back to the same screen. That was silly. Where are you? Oh, that is, here it is, Excel. Here it is, 73.226. All right. So what I did in the spreadsheet was I calculated the square roots first. I did it for here, and then I just copied it over and added 1 inside the square root to give me the square root for the prediction interval. Okay. And by the way, this number times the standard error of the estimate would be the standard error for the prediction interval. Okay. If you look in the formula in your textbook, it has s times that square root, which has the 1 plus inside for the prediction interval. So this is the square root for the prediction interval. This number times 91.47893 would be the standard error for the prediction interval. And then if you multiply it by the critical value, you get your margin of error. Remember, margin of error is critical value times standard error. Critical value is this number here, right? Depends on what you put in for the confidence level here. This is a 99% confidence interval, 99% prediction interval. And then what is the standard error? It's this number, the standard error of the estimate, times the square root, whatever the square root is up here. This is the square root for the confidence interval. This is the square root for the prediction. And that gives us our standard error for each one of those things. All right. So T, the critical value, times the standard error, which is this number, times this number, or times this number, depending on whether you have a confidence interval or a prediction interval. And then if you add and subtract that, right? And that of course gives you what? The margin of error, right? The margin of error is what? The margin of error is the t times this number times this number times either this number or this number, giving me the margin of error for the confidence interval, the margin of error for the prediction interval. And then of course I just added and subtracted from what. You have to be careful here. It's the y predicted. You're taking the y predicted plus or minus the margin of error gives us the left and right endpoints of the interval, whether it's a confidence interval or a prediction interval. Okay, I did all the heavy work for you here, all these formulas. You want to see what some of these formulas look like? Probably not. The square root formulas, that's it.
Wow.
That's for the square root for the confidence interval. That's the square root thing. This is for the prediction interval. All right. Very easy to make mistakes with that. I had to make sure it matched everything correctly. All right. Fortunately, I had Minitab to double check to make sure I didn't make any errors. So that's it. This gives me the confidence interval for each value of x. And then if I wanted to do this for a different value of x, such as 10, and I have my predicted value here, right? Now, I can simply copy down these formulas. I can copy all of this here, all the way down to that. I'll copy it and then paste it down here. Okay. Now, for some reason, I'm getting 0 here for the confidence and why am I getting that? Why am I getting 0?
The formulas?
Well, probably because
We don't
let me
have a
see.
y.
No, I don't need a y. I need a y hat, which I have here. Actually, I don't need a y hat for the margin of error. I need an x, but I have my x. What am I missing here? Oh, I miss. Do I need these square roots? You bet, right? I need the square
I think
roots.
G9.
I forgot about the square roots. So let's do that. The square roots have to be in there too. Copy. Go down to here. Paste. There we go. You need the square roots in these formulas. So here's my confidence interval. Well, first of all, I have my predicted value, right? And what else do and that was a formula, right? I just copied it down. I have my x, right? And then I just copied the formula starting with the square roots and just copied it all the way down. And I get my, everything I need. I get the square roots, I get the margin of errors for both confidence intervals and prediction intervals. I get my lower and upper limits for confidence intervals and prediction intervals. Notice, let's double check to make sure this matches Minitab. I get about 310 up to 553 for my confidence interval. So let's go back to Minitab. Yeah, that's it. So it matches. Then this is 71 to 792. Let's make sure that's the prediction interval. Back to Excel. Yeah, 71, 70, 92. So it matches. It works. It works. So this is a spreadsheet that does everything that Minitab's doing. But what's better about this is it's giving me, I'm getting all this from what? The actual slope and the actual y-intercept, as opposed to some approximation. They should have given you something like this, obviously, right? They should, but they don't.
You should write to them something.
What's that?
Nothing.
They don't give you, by the way, they don't give you the standard error of the estimate, which is for the overall. the 91.478. I don't think, if we go back, I don't think they give you that at all in Minitab. If I ask for that, let's go back. The standard error of the fit, by the way, is doesn't 54.9228. Let me think about this for a minute. Yeah, this doesn't match that. So this is certainly not the answer. The standard error of the estimate is not this number. All right. You would think it is. You would think it would be, but it's not. This must be the standard error of the estimate times something. I don't know what it's times, but this is not. If I ask for the standard error of the estimate, don't give you this number. You'll find it in Excel in that spreadsheet. All right. So the spreadsheet's going to give you the answer. Now the spreadsheet, let's go back to the spreadsheet for a minute. That standard error of the estimate is dependent on what? It's dependent on, let's see, what is it dependent on? I13. Here, it's dependent on the residual squared, the sum of the residual squared, that's this number here, divided by, and it's the square root of this, the square root of this number, right?
Mm-hmm.
Times, divided by the number of values here. Now, you have to modify this spreadsheet if you have more than 8 XY points.
Mm-hmm.
You have to modify it. But I hope you can figure out how to do that, right? You're going to be copying all these formulas down until you get to the very end, right? You just have to look at the formulas, just modify where they end as opposed to, right? Because they all end at row 12. So if you make sure you start at 5 and just keep going down, and then wherever row you end up with, you just change the formula. So instead of ending at row 12, they end at that row. You have to make sure all of them are like that. All the formulas are like that. So that I can't control. You have to figure that one out, where it ends. I'm sure there's an Excel function that does that, right? That tells you where it ends and all, but I'm not getting into all that. But this at least will be helpful to you. This will give you some idea how to do, come up with all of this, all right? But just know that the y-intercept and the slope can be figured out here, and also the standard error of the estimate can be figured out here. You can change the confidence level to whatever the problem says. Just type it in, 0.99. Remember in Minitab, it actually you had to put in 99, not 0.99, but 99. So it's assuming it's a percentage there, which is
Right.
I know it didn't tell you to. There was nothing to prepare you for that. You didn't know. That's why I think having Excel here helps a little bit so that you can double check things. Critical values here. By the way, the formula is already set up for the critical value. Okay. In this case here, the only thing that you have to change, if there's a different ending to your X's and Y's, you just have to change the ending value, ending row. Yeah. If it ends in row 30, it just changes the 30 over here. As long as you start at 5 and end of 30, you should get the correct critical value. This is also pointing to what? It's pointing to the confidence level here. This is a correct critical value. All right. So all of these numbers here, they're all of these that are listed in this G column depends on when the data set starts and when it ends. If you start the data set at the same place and then figure out where it ends, you just change those ending values and then you should be good. Okay. And then if you have to change these formulas too, you know, the square roots, notice there's 12 here, and there's, well, you don't change anything that says 14 or any other number, but you certainly want to change the ones that are running from 5 to 12. You want to change it from 5 to whatever the ending value is.
Right.
Just be careful. Yeah, just be careful not to do it like here, right? This is not the ending value of the data set. This is what? The mean. So you have to be careful, all right? You have to be careful. All right. So this is ready to go. I'll post it. And question is, I've showed you quite a bit here. I've shown you pretty much everything, right? Correlate. I showed you where to find it, pretty much everything in this book. You look on page 589. What are they going through here? They go through the line of best fit. That's just least squares regression line. You know how to do it here, and you know how to do it exactly in here. The standard error of the estimate. That's G7 here. The confidence interval for the mean of y. And you have to remember the confidence interval is giving you an estimate for the mean of y. Oh, all right, given a specific value of x, and the prediction interval is giving you for a prediction for a particular value of y given that, not the mean, but a particular value for a particular person. So the prediction interval is always wider than the confidence interval. And then the correlation, we know where to find it. You don't have to use the formula, right? You know where to find that now. And the coefficient of determination we went over. So everything on this page you can do. Oh, there's another page. That's page 590. To show you the different types of tests. Am I gonna ask you for a t-test for the coefficient of correlation coefficient? Well, would I do that?
No.
Well, what is the null hypothesis? That the correlation is 0. And the alternative hypothesis
Right.
that it's different than 0. I would say in most cases it would be different than 0. But how would you test it? You would come up with this t-statistic, which it's actually not that hard. It's r divided by that square root, 1 minus r squared divided by n minus 2, the degrees of freedom. You have your t-statistic, right? And then, once you have your t-statistic, since this is a two-sided test, you find let's say the t is positive. It should be positive. Well, actually, it'll be negative if r is negative. It'll be positive if r is positive, right? But when r is negative, you will find the area to the left of that t-statistic, and that will be half your p-value, because it's a two-sided test. So you multiply that by 2. If the t is positive, you find the area to the right, and that's your half the p-value. You multiply that by 2, and then you compare that to whatever alpha is. Alpha will be quoted, and then if the p-value is less than alpha, then we reject the null hypothesis that the correlation coefficient is 0, and we state that it's non-zero. It's significantly different than 0, and that's the t-test for correlation coefficient. So it's like any other t-test. It's just the t-statistic is different. That's all. Done exactly the same way. And it's a two-sided test, always a two-sided test. So we have to make sure that whatever area that we find, right, whatever, it's one that we have to multiply by 2 because it's a two-sided test. Here's a t-statistic. The next one is a t-test for the slope. All right. Oh yeah. I'll be off in 2 minutes. My wife has to use Zoom, so I have to get off in a minute. Well, for the slope, it's the same thing. Maybe it's hypothesized that the slope is 0, or it could be something else. And then the alternative hypothesis is that the slope is something other than that. And look at the t-statistic. What is it? It's just the estimated slope minus the hypothesized slope divided by what's SB1? That formula down there. It's the right. It's the standard error of the estimate divided by that square root there. So you could do this too. It's the same, comes up to the same idea. You could do that if you want. So I'm not going to ask you anything else, but I just wanted to point out to you that you have the means to do this. And if I ask you, maybe not on a test, but if I ask you on this project to run these tests, this is the page you look at, and you can figure it out. Try it. Don't be scared. Give it a
Okay.
shot. You can do it in Excel. Or with a calculator, whatever you would like, but you can do it. You can do it. Okay? So that's it.
I wish I do.
That's it. So my wife's chasing me off Zoom, so because she has to get on in 5 minutes. But it was a pleasure teaching you. Let me actually stop sharing this. So let me just tell you what's coming up. You've handed in your homework, which is great. I will have that graded over the weekend. The project, I will, with the data set, I will post tomorrow night. By tomorrow night, you'll see it. And it'll be worth 50 points, I think 50 points. And it will ask you to do some of everything that I've showed you today, plus maybe a couple more little things that I showed you on page 395. I'll think about it. I'll think. Don't be scared. Don't be scared of it. You can do it. All right. The point of this course is to learn how to use software and learn how to do things on your own. So you can try it. I'm not going to probably test you on page 590, but I could certainly test you on 589, anything that's there, because you're going to be able to use software in Excel to figure these things out. All right. But I will give you a data set, and I'll clean it up to make sure it's ready to go. And it'll be in Excel. It'll be a data set that's available to you in Excel. And then I'll ask you a series of questions. And then you'll follow these procedures that I went over tonight, and you'll be able to answer them. All right. And don't worry, it will not be hard. All right. Everything I went over tonight, you'll have available. I will post this Excel spreadsheet for you and all of that. So, all right. So don't worry.
And the project is due on Sunday night?
Monday, I believe I said Monday night. Didn't I say Monday? Or did I say Sunday?
Okay.
Monday. Monday at 11:59 is when the project is due. I'm giving you an extra day. So, and then the test itself is on Tuesday. This project, by the way,
Okay.
will help you with the test. It'll help you with the test. It's a way of reviewing regression without actually reviewing regression, because it'll give you pretty much everything that I could test you on.
Okay.
But whatever I ask you on a test, it'll be a simplified version of what the project is, obviously, because of time constraints. And it'll be a 90-minute test, 22 multiple choice questions, just as before. All right. So that's it. Semester's almost over. Yeah, go ahead, Todd.
If I have more questions about chapter 9 through
Yes.
11, can I talk to you?
Yes. Yes.
Through email or Zoom later, maybe? Yes.
And Steve, it's the same to you. If you have any questions, you can. Yes.
Okay.
The answer is yes.
Okay.
All right.
Okay.
Anyway, I'll stop the recording. And again, it was very nice teaching you.